These are the answers to problems 5, 6, 7, and 8 on the constant velocity worksheet. Number 5, you were driving your car down a road doing 23 meters per second. Suddenly a child runs out in front of your car. It takes you 0.75 seconds to take your foot off of the gas and hit the brakes. How far do you travel before you even start to slow down? We're looking for the displacement here. That's our question mark. So our equation is displacement equals velocity multiplied by time. We were given the velocity at 23 meters per second. We were given a time at 0.75 seconds. Multiply the two together, and you get 17.25 meters. Number 6, you are riding your bicycle down the road for 1 hour, which is 3,600 seconds. After an hour, you check your GPS and realize you've traveled 31.4 kilometers, or 31,400 meters. The question is, how fast have you been going? What's your average speed over this length of time? Well, velocity is displacement divided by time. The displacement was given at 31,400 meters. The time was given at 3,600 seconds. Divide those two numbers, and we find out you've been going 8.72 meters per second. Number 7, a high school athlete runs the 100-meter dash, so there's our displacement, 100 meters, in 12.2 seconds. There's our time. The question is, what's the average speed of the person during that race? Well, the velocity is displacement over time. Displacement was 100. Time was 12.2 seconds. Divide those two numbers, and you get 8.2 meters per second for your average velocity. Number 8, this is a challenging one. A tourist is being chased by an angry bear. There's my picture of an angry bear. And they're running in a straight line toward the car at a speed of 4 meters per second. So that's the person running right there. The car is a distance d away. We're not sure how far away the car is. We do know the bear is 26 meters behind the guy and is running 6 meters per second. So the tourist reaches the car safely. We're going to just say that, which means what distance could this be before the bear would have caught him and eaten him up? So we want to figure out what is the maximum distance this d could be. How far away from the car could you be before the bear would have caught you? You would not have been able to outrun him because he's running faster than you are. There are a couple ways that we can think about this problem. We'll start at the end. We'll sort of think about it, and we won't do the math, and then I'll show you where the math comes from. So one way that you can get this problem is to take a look and say, okay, the guy is running 4 meters per second. The bear is running 6 meters per second. That means every second, the bear is getting 2 meters closer. Because after 1 second, the guy's gone 4, the bear's gone 6. After 2 seconds, he's gone 8, the bear's gone 12. So every second, the bear is getting 2 meters closer to the guy. So how many seconds would it take for the bear to catch up 26 meters? Well, if it's 2 meters every second, then it would take half of the distance is 13, so it would take 13 seconds. Okay? So after 13 seconds, the bear will have caught the guy, which means the guy cannot possibly have to run for longer than 13 seconds or he will get eaten. Well, 13 seconds, if he's running 4 meters per second for 13 seconds, we'd multiply 4 by 13, and you get a total distance of 52 meters. If this d is bigger than 52 meters, the guy will get eaten. If you did not follow that, that is okay. That was just sort of doing it in our head. Here's the mathy way to do it. I'm going to write down my bear stuff. I'm going to write down my guy stuff. Remember, we're headed towards an answer of 52. Right down here. You'll see it. But if you didn't understand the first part, here's how we got it. The bear, his distance, I'm just writing down his displacement, his velocity, and his time in a little column. For the guy as well, displacement, velocity, time. The displacement for the bear, he's going to have to go whatever distance it is from the guy to the car, plus 26 meters if he's going to get to the car. That's how far he's got to go. Whatever this d is, plus an additional 26 meters. The velocity of the bear is 6 meters per second, and we do not know how long it's going to take the bear to get there. When we start this problem, we weren't sure how long it was going to take the bear to get there. For the guy, we don't know how far away he is from the car. That's what we're trying to find. We want this distance or displacement, how far away the guy is from the car. We know his speed is 4 meters per second, and we're not sure how long it's going to take him to get to the car because we don't know how far away the car is. All right, so I have my equation, which is displacement equals velocity multiplied by time. I have that for the bear. I have that for the guy. So here's bear stuff, guy stuff. Well, where I have displacement of the bear, I'm plugging in d, that's the d from the picture, plus 26 meters. So instead of displacement of the bear, I've got d plus 26 meters. That's going to equal the velocity of the bear multiplied by time. I didn't mess with this right side of the equation. For the guy, Well, the guy's displacement is just the d that we were looking for, this one right here. It's the same guy right there. This d and this d are the same thing. It's the d from the guy to the car. And that's going to equal the velocity of the guy multiplied by time. I rearranged this equation right here a little bit. I just subtracted the 26 meters to the right side. That's why it's now over here on the right with a minus sign. That's all I did. So now I've got d equals velocity of the bear multiplied by time minus 26 meters. Here is the d equals velocity of the guy multiplied by time. I have a simultaneous equation. I do not know what d is. I do not know what time is. I do not know what d is. I do not know what time is. What I'm going to do, the easiest way to do this is to just solve for time first, because this equation is set up equal to d, and this equation is set up equal to d, which means that this equation and this equation are equal to each other. So I set those two things equal to each other, and on my left side of the equation, I've got this, velocity of the bear multiplied by time minus 26. Notice that's on my left side of the equation. On the right side, I've got velocity of the guy multiplied by time. That's on the right side of the equation. Now I'm going to solve for time. I'm going to try and get both terms, the v times t and the v times t, both of those terms with time in them, to the same side. How I'm going to do that is I'm going to subtract velocity of the guy multiplied by time over to the left. But I also don't want this 26 meters here, so I'm going to add my 26 meters, it's the negative sign here, I'm going to add it over to the right. I'm going to do that in the same step. So now vg, velocity of the guy multiplied by time, is subtracted over, now it's on the left side but with a minus sign. The 26 meters was added to the right side, so that's why it's on the right side now, but now it's positive. I'm going to factor my time out of each of these two terms, leaving me with time and the velocities in parentheses, the VB minus VG, right there. That's going to equal 26 meters. I'm going to divide what's in parentheses over to the right side. That's why down here is underneath the 26. And now I can plug in my numbers and solve. 26 meters over 6 minus 4. 6 minus 4 is 2, so 26 divided by 2 gives me 13 seconds. I know we talked about that at the very beginning of the problem, we just sort of thought about it, but that's the mathy way to do it. If the numbers were more complicated, you might have had trouble trying to think it through, and you might have had to do all the math. So that's how we do it. Once we get the time, we can plug that 13 seconds in to either one of these equations. I'll use the guy's equation because it's a little bit easier, and I'll tell me how far the guy had to run. So I know he's going to go 4 meters per second. We just solve for the time. It's going to be 13 seconds. So 4 times 13 gives me a distance or displacement of 52 meters.